body side. Alright, so the angle is okay, so right away you see a big difference between this and the wing. Mainly the flow is laminar all throughout, and then a little bit after where the body ends you start getting turbulence, right? You start getting turbulent flow. You guys see that? That makes sense. Okay. And it's almost as if like the flow twirls back and then goes in the direction it was going. Yeah, I'm sorry, the blue's on. Oh shit, where's the green?
The green's on.
No, I know. It's not coming up. Oh, fuck.
What was coming on first?
Huh. Okay, whatever. Come on the other side. We'll deal with blue. Alright, so you got. Oh, dude. I just want you to see it. Forget about the write up. You just qualitatively describe what it is. Alright, so blue dye, laminar everywhere, other than when you get to the end. So, and you'll learn about this, where the body ends, the flow no longer has anything to cling to, so it starts getting turbulent, starts mixing. And then like we increase the angle of attack. Now you'll see the dye is kind of just, the main point is the flow follows the body. So now that the body's at an angle of attack, the dye goes up and goes down. It's starting to go over the body a little bit. And that's like exactly what happens in airplanes, where if they have swept wings, you see that? Oh, here. Sorry. Okay. No, it's good. A lot of airplanes, especially airliners and fighter jets, their wings look kind of like that, right? So what happens is when the air comes in, it sticks to the wing, has no slip condition, and then the rest of the flow starts developing. It's called span-wise flow. So the flow starts going down this way, and that's what's happening on the body. You guys good? Get that? Okay. So now let's make this work for stall. It's just dye coming out. Okay, so as the angle increases, you guys can see like the flow starting to separate at the end. See how it's doing this thing? But it's not nearly as intense as it was with the flying wing, with the delta wing. And I think we're already at around 10, 12 degrees. If we crank it up higher, oh, I guess we get a little bonus section there. Okay, so you guys should be able to see down here. Let me kill this for a second. Okay, see how the flow is detached, like way faster, or earlier than it was before. That's too much dye. And now you're starting to see, you're starting to get some vortices right above the forebody. Vortices create turbulence all the time. So that's basically it. This lab is all about visualizing flows. If you guys can get an accurate like angle of stall for the delta wing, that's a plus. But so what I mainly want to see in the report is you qualitatively describing the flow at every angle of attack and trying to extract a relationship between how high the angle of attack is and how turbulent or laminar the flow is. I think we covered that extensively, but that's basically it.